test for the 18650 and 21700 battery cells. This one's right here is for 18650. You can see. This one is for 21700. So we're gonna run some tests on this newer testing machine. We're gonna try to push these cells to the max and really see which ones are the best. All right, y'all, today I'm testing the 2 lithium-ion cells. So I wanna kind of see how they perform under real world loads. So this is the test parameters. I wanna show you guys how the test parameters are set up. So first, right out of the gate, we're gonna do our charging setup. So as you can see here, this is like the charging setup. We're gonna do for this one constant current to constant voltage. So we're gonna charge it up to 4.2 volts at 1 amp. And once it hits full voltage, we'll taper it down to about 0.2 amps. The sheet says 0.1, which is 100 milliamps, but I'm going to do 0.2, just the safety of the cell. I don't want to make sure I'm trying to get above 4.2. It wants to be at 4.2 volts. So whenever you want your test you want the battery to not go above, you want to set those limits. So 4.2. I'm gonna rest it for 1 minute after that, and then we're gonna go straight into constant current discharge. So the next cycle for this test range, we're doing this because we want to have just the range. We want to have like a low amp draw, so we're going to do the range. This simulates, like the regular low power that you'll see for maybe it's light, maybe the if it's on the e-bike, the person is really helping pedal, so you see a lesser amperage draw. So this is what the first test is just showing for range. Now, when we get down to cycle test number 2, which is going to be our power test, you can see we have 10 amps here. That's going to be when we push the battery so hard with a 10 amp discharge. We're going to have the cutoff voltage set to about 2.5 volts for the cutoff. This shows how the cell will perform under a big load. Like if you're, trying to use a power tool, or like a vape cell, or, even if you're using like a power scooter and it has like a really high range draw. So if you're like trying to pop a wheelie with a bike and you go to push the throttle, these types of cells can handle it. So the 10 amps are just one of the settings on it. You see it here, 10 amps, and then we have our 2.5 for cutoff voltage. Final, we're going to do our rest and final charge. I also added the rest period between stops to kind of give the cell times to cool. So you can see rest, 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 rest. I did this so that way you can give the cell some time to cool. That's key to avoid thermal distortion in the data. So that way we want to not have, have it back to room temperature once we get these charged up again. So you see I have those in place. Actually, this first one, I'm going to change this one to 5 minutes as well. Just try to keep it consistent. The first rest period is just 1 minute. The battery's been sitting out, so that's fine. And then in between, I'm gonna have 5, 5, and then 30 and 30. After the discharge, you'll need a little bit more disparity in time because you want to have it come off from discharge. And again, to wrap this up, with this program, I'll be able to measure both range and power in one clean cycle. This allows me to help decide whether the cells are good for everyday use or which can take some serious heat. We're in Las Vegas, so we want to make sure that we build the batteries with the right ones that the customers need. We have to build to our elements. So this is what this test is for. Let me know if you guys ever want some different testing done, but this is going to be my range and power test. All right, so now we got this test. Let's get it started. So we'll go to single start and we'll load it. All right, so we have loaded the test. You can see it here. So now we're just gonna go and start. So we're just gonna go hit start and we're gonna run it. You'll see they go to rest, and after a minute, they'll go into our test. All right, here is the completion for the LG 21700 M52V. So this is for the M52V. You can see here we have the first test where we charge it up. You can see constant current charge. You can see we went up to the end voltage of 4.2. And then here we discharged it. Nice capacity. Nice capacity of 5.2, 5.26. And then we went down to 2.4, 2.5. And then we rested and we constant current, constant voltage up to 4.2 again. And we charged up. You can see the charge up capacity here. And then the constant current discharge at 10 amps. You see, the 10 amps, 10 amps, negative 10 amps. And then you can kind of see the capacity when we did the hard 10 was 4.9, so really good. I would say this cell performed relatively well, kind of exceeded expectations on the range test, and on the power test it held up pretty decent. Right at 5, 4.96 is pretty much 5, so that's not bad. Again, we can kind of see the graph over here to the left. Let me open it up for you guys a little bit so you can see it. So you can see we have our voltage here at the top. You can see the voltage going up, and you want to pay attention to this line, this line where you see 4. This is your 4 line, so you can kind of see it goes up to above 4, and then we drop it down almost to, let's say, 2.5. This is like that little 2.5 niche, 2.5. So the voltage is here. You can see smooth curve, had a little jump there. It may be me pausing the event just because it took relatively 2 days to run this testing. I run 8-hour shifts, so you can imagine the batteries take a little bit longer than that because we're draining really slow. So you see a little gap right there, but again, data is smooth in terms of on the discharge. And then here you have your current, which you can see here is in the darker blue color. It's on this side, the left side of the graph here, and you can see where it's at 0 and a little bit below that line would be 1. So we're discharging negative 1 amp. As the voltage drops, you see as the voltage drops, the current goes up, and then we do the next cell testing cycle of the negative 10 amp power discharge. You can see that here. You can see the voltage drop relatively fast. You can see here is the capacity. The capacity goes up and go down, up, down. So smooth graph there. Let's kind of go back and we can see the export file. So I'm just going to go here and save this file. Save as. I'm going to save this as our M52V. So still an LG cell. Maybe I should put LG. I know it, but someone else may not. So I'll put that there. And then we're going to export this. It's already up now, so we did the last one. So we're just going to call this again LG underscore M52V. And then export. And yes, open. Again, so relatively the same graph. You see we got the serial number where we saved it. You can see kind of where we have the constant current charge. Sorry, let me zoom in a bit here. Zoom in a bit. Yeah, so you have the recording layers. It's pretty straightforward. This is where we charge up. So you see a positive 1. We're charging up 1 amp. And then you see as we go down, we have all the data. You can actually see the current start to drop. You can see 0.9, 0.8, 0.7, 0.6, and then it goes all the way down to 0.2, 0.1, and then 0, of course, while we're resting. And then we go to constant current discharge. We are discharging at negative 1 amps. So you can see all of the data points there. And then finally, so long, this one, of course, takes a while. You see we have the rest stage for about 30 minutes. Then it's constant current to charge it back up again to do our power test. You see all the positive ones. And then we'll go to another rest period. So you'll see some zeros here. Yep, starting to get down. So here's that rest period I talked about. And then now you have the negative 10. And then the battery shuts off here. And then we charge back up again. So this concludes the M52V cell from LG. Again, I'll post these on our website so you guys can see the results. Thank you for this test.